In this chapter, we will talk about matter in detail. So the first question is, what is matter? Everything in this universe is made of material which scientists have named matter. Matter has both mass and volume. Volume means occupies space. Suppose you are given a list of things or objects and you have to identify which one is matter and which one is not. Then you should see which object has mass as well as volume. That will be matter. For example, a pencil is a matter as it has mass and volume both, whereas something like anger, love, hate has no mass or volume, so they are not matter. Matter is classified based on its physical and chemical properties. In this chapter, we will learn about matter based on its physical properties. Now let us talk about physical nature of matter. Earlier there were two beliefs. First, matter is continuous like a piece of wood, and the second, matter is made of particles like sand. Let us do a small experiment. Take a beaker, put some water in it and note down the water level. Now add 2 teaspoons of sugar in it and stir vigorously to mix it completely in water. Now check the water level again. Has it increased? The answer is no. Why? The explanation is when we dissolve sugar in water, the particles of sugar get into the spaces between the particles of water. This proves that the matter is made of particles. There are 3 characteristics of particles of matter based on which several phenomena are explained. First one is particles of matter have a space between them. So if these are the particles, you can see space between them. Second one is particles of matter attract each other. Every particle experiences a force of attraction with other particles. This force keeps the particles together. The strength of this force varies from one kind of matter to another. Third one is particles of matter are continuously moving. You can see particles moving in all the directions. They possess kinetic energy. With increase in temperature, kinetic energy of particles also increases. As a result, they start moving faster. Now let us understand what is diffusion. Suppose these are particles of matter A and matter B. If they intermix with each other on their own, this phenomena is called diffusion. To understand it more clearly, take a vessel, pour some water into it and add 2 teaspoons of salt into it. Leave the setup for a few hours. You will observe slowly all the salt has dissolved into the water. So you can say that the salt has diffused into the water. So what happened in this case is salt particles occupied the space between water particles. Does diffusion always happen when two matters are mixed? Let us find out. Take 2 tablespoons of salt and 2 tablespoons of sugar and mix them together. Leave the setup for few hours or even few days. Do you observe any change? Did the quantity of sugar or salt decrease? The answer is no. So we conclude that diffusion does not always happen when two matters are mixed. On heating, rate of diffusion increases. Suppose you start heating this vessel, then salt particles will quickly diffuse into the water. Now some examples of diffusion. You may have smelled hot sizzling food, perfume, burning incense sticks or camphor even if you are at a certain distance away from those objects. This happens as the smoke contains gas particles which travel faster in the air and reaches your nose. Every matter is made of some material and every material is made of particles. All the particles of a material possess same characteristics. Now we will study about states of matter. There are 3 states of matter: solid, liquid and gas. These states of matter arise due to the variation in 3 basic characteristics of a material, such as increase or decrease of distance between particles, increase or decrease of force of attraction between particles, or increase or decrease in kinetic energy of particles. Suppose these are 3 identical containers. In first there is solid, in second there is liquid, and in third there is gas. Their respective number of particles and arrangement is shown here. Now we will do a comparative study based on various characteristics or properties. It is clear from this figure that the number of particles in a fixed volume is maximum in solids and minimum in gases. That means density of solids is maximum and density of gases is minimum. First property is arrangement of particles. You can see particles in solids are very close to each other, whereas particles in gases are far apart. Second property is space between particles. You can see space between particles in solid is very less as compared to space between particles of gas. Third property is force of attraction between particles. Particles of solid are very close to each other, so their force of attraction is more as compared to particles of gas in which particles are far apart. Fourth property is movement of particles. You can see particles of solid are very close to each other. Due to a strong attraction force between them, they are not able to leave their place. They just vibrate at their mean position. On the other hand, particles of gas have least attraction force between them, so they can move freely. Fifth property is kinetic energy of particles. Particles of gases have greater kinetic energy as compared to particles of liquids and particles of solids. Due to this, they move freely at high speed. Next property is shape. Solids have definite shape. For example, pen, pencil and books have definite shape. Liquids don't have any specific shape. They take the shape of the container they are poured in. Gases have no shape at all. Next property is volume. Solids have definite volume. For example, how much space a box will occupy is definite. Liquids too have definite volume, as we say 5 liters of water, 2 liters of oil. Gases don't have definite volume. Volume of gases is same as the volume of the container they are filled in. Next property is rigidity. Let us understand its meaning first. In physics, rigid body means a solid object which cannot be deformed no matter how much force is applied on it. It may break, but it will not change its shape. Solids are most rigid and gases are non-rigid. Next property is compressibility. Let us understand its meaning first. This is a syringe which is made of 3 parts. Middle part is cylinder, upper part is piston and the bottom one needle. When piston is pushed down the cylinder, pressure is increased on the air inside and its volume decreases. As a result, air gets compressed. If liquid is filled in place of air, more force is required to push the piston. If solid is put in the place of air, probably piston may not get pushed down at all. So we can say gases are most compressible and the solids are least compressible. If piston is pulled up, pressure on the air inside decreases and its volume increases. As a result, air gets decompressed or expanded. Next property is fluidity. It means property to flow. Gases are most fluid than the liquids. Solids don't show this property. Last property is diffusion. As we have studied in last episode, when two different types of materials mix with each other on their own, this phenomena is called diffusion. Solids to solids diffusion is rare and gases to gases diffusion is common. Now we will see some examples of various types of diffusions. Example of solid to liquid diffusion is sugar in water, solid to gas, camphor in air, liquid to solid, seepage on walls, liquid to liquid, fruit juice in water, liquid to gas, fog in air, gas to solid, rubber sponge, gas to liquid, oxygen in water, gas to gas, oxygen in air. Solid to solid diffusion example can be, suppose tomato ketchup falls on the floor tile. If it is left as it is for months or years, slowly water content in it will evaporate and ketchup will diffuse into the tile. Later, if you try to clean it, that part of the tile will still look dirty. There is one practical application of compressibility of gases from our day-to-day life. We have studied that gases are highly compressible, so large volumes of gases at high pressure are filled in small cylinders and transported easily. One question arises, why gas cylinders are made of thick steel sheet? As we know, gas particles have most kinetic energy. They move freely. Inside the gas cylinder, they collide with each other and also with the walls of the cylinder. This creates pressure on the walls. To withstand this pressure, cylinder has to be very strong. That is why it is made of thick steel sheet. State of matter can be changed by change in temperature or pressure. Let us see how. First, we will see the effect of change in temperature. Due to slowly increasing temperature, kinetic energy of particles increases and force of attraction between particles decreases. As a result, solid particles which were vibrating at their mean position overcome the force of attraction with other particles and start roaming around freely. In this process, solid changes to liquid and liquid changes to gas. What happens during state change? Let us understand by an experiment. Take some ice cubes in a beaker and put a thermometer in it to measure the temperature. Start heating the beaker with the help of a Bunsen burner. In the beginning, temperature of ice was minus 20 degrees centigrade. Slowly the temperature of ice rises to 0 degrees centigrade, which is its melting point. It means ice will start melting now. By definition, at 1 atmospheric pressure, melting point is that minimum temperature at which solid starts changing to liquid. Temperature remains constant at 0 degrees centigrade till the whole ice melts and changes to water. It means during state change from solid to liquid, temperature remains constant. Now the same process will be repeated while liquid changes to gas. Let us see how. As the temperature of ice kept increasing till it reached its melting point, similarly temperature of water will keep increasing till it reaches its boiling point, that is 100 degrees centigrade. At 0 degrees centigrade, ice started melting. Temperature remained constant at 0 degrees centigrade till the whole ice melted and changed to water. Similarly, at 100 degrees centigrade, water starts boiling. Temperature remains constant at 100 degrees centigrade till the whole water boils and water changes to vapor, that is, liquid changes to gas. Whole process is summarized on the right. From figure 1 to figure 2, only temperature rise of ice, no state change. From figure 2 to figure 3, only state change from solid to liquid, no temperature rise. From figure 3 to figure 4, only temperature rise of water, no state change. From figure 4 to figure 5, only state change from water to water vapor, means liquid to gas, no temperature rise. Now let us see the definition of some keywords related to this process. First one is melting point. At 1 atmospheric pressure, the minimum temperature at which a solid melts to become a liquid is called its melting point. Second one is fusion. The process of changing a solid to liquid state is known as fusion. Third one is latent heat of fusion. Let us understand the latent heat first. We have seen in the above experiment that continuously supplying heat does not always change the temperature. During state change, temperature does not change. So what does heat do in this phase? It helps in melting the ice and boiling the water. It remains hidden, so it is called latent heat. Latent heat of fusion is defined as the amount of heat energy required to change 1 kilogram of solid to liquid at atmospheric pressure and at its melting point. Next one is boiling point. At 1 atmospheric pressure, the temperature at which a liquid starts boiling is known as its boiling point. Next one is vaporization. The process of changing a liquid to gaseous state is known as vaporization. Next one is latent heat of vaporization. It is defined as the amount of heat energy required to change 1 kilogram of liquid to vapor or gas at atmospheric pressure at its boiling point. The process of changing ice to water vapor is plotted on the graph as shown in the figure. At point A, ice is at minus 20 degrees centigrade. From point A to point B, temperature increases to 0 degrees centigrade, which is melting point of ice. From point B to point C, ice changes to water and temperature remains constant at 0 degrees centigrade. From point C to point D, temperature increases to 100 degrees centigrade, which is boiling point of water. From point D to point E, water changes to water vapor and temperature remains constant at 100 degrees centigrade. From point E to point F, temperature of water vapor increases. By heating, solid changes to liquid and liquid changes to gas. By cooling, gas changes to liquid and liquid changes to solid. The process of solid changing to liquid is called fusion. Liquid changing to gas is called vaporization. Gas changing to liquid is called condensation. Liquid changing to solid is called solidification. It is possible to change solid directly to gas or gas directly to solid bypassing the liquid state. The process of solid changing to gas is called sublimation and gas changing to solid is called deposition. SI unit of temperature is Kelvin, which is denoted by letter capital T. There are two more units, Celsius and Fahrenheit. Numericals based on temperature calculation in these units are asked. These two formulas will be used. We will see numericals in next episode. We have seen effect of change of temperature on a state change. Now we will see effect of change of pressure on a state change. There are two cases when pressure is increased and when pressure is decreased. We will see case 1 first. This is a cylinder, this is a piston and gas is filled inside it. If you push the piston down the cylinder, pressure on the gas will increase, the distance between particles will decrease. Slowly gas will change to liquid and liquid to solid. By this process, carbon dioxide changes to solid carbon dioxide, which is also known as dry ice. If you pull the piston up, pressure on the solid will decrease and a state of solid can be changed to liquid and then to gas. That is, solid carbon dioxide can be changed back to carbon dioxide gas. Now we will understand what is evaporation. We know that particles have kinetic energy. Due to this, in case of solids, particles vibrate at their mean position, whereas in gases, they roam around freely. In case of liquids, a small fraction of particles at the surface absorb heat energy from the surroundings and gain enough kinetic energy to break away from the forces of attraction with other particles and get converted into vapor. This phenomena of change of liquid into vapor at any temperature below its boiling point is called evaporation. There are four factors that affect the rate of evaporation. First is surface area, second temperature, third humidity, and fourth wind speed. Evaporation is a surface phenomena. If surface area is increased, evaporation increases. For example, while drying cloths, we spread them out. By increasing the temperature of the surroundings, more particles get enough kinetic energy to evaporate. So rate of evaporation increases. Humidity means amount of water vapor present in the air. If humidity is more, air cannot hold more water vapor at a given temperature, so rate of evaporation decreases. If the wind speed is more water particles move away with the wind, so rate of evaporation increases. Evaporation causes cooling. Particles of a liquid absorb energy from the surroundings and get evaporated, making the surroundings cool. Now let us see these two questions. Why should we wear cotton cloths in summer? The answer is, in summer we sweat more. Cotton is a good absorber of water. It absorbs sweat and exposes to air to evaporate. As an effect of evaporation, our skin feels cool. Second question is, why do we see water droplets on the outer surface of a glass containing ice-cold water? The answer is, the water vapor present in the air when comes into contact of outer surface of the glass loses its kinetic energy and gets converted to liquid state, which we see as water droplets. Let us see questions and answers of this chapter. First one is, which of the following are matter? We will see which ones have mass as well as volume. First one, chair. Chair has both mass and volume, so chair is a matter. Air. Air is a mixture of gases. It has both mass and volume, so air is a matter. Love is a feeling. It has no mass or volume, so it is not a matter. We smell the air particles, which is a mixture of gases. It has both mass and volume, so it is a matter. Hate is a feeling. It has no mass or volume, so it is not a matter. Almonds has both mass and volume, so it is a matter. Thought is a feeling. It is not a matter. Cold is a feeling. It is not a matter. Lemon water is a matter. Smell of perfume. It is a matter as it contains gas particles. Second question is, give reasons for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. The answer is hot sizzling food has gas particles that have high kinetic energy. They quickly diffuse in the air and travel a long distance. On the other hand, cold food has gas particles that have low kinetic energy. They cannot travel even a small distance. That's why you need to go close to them to smell. Third question is, a diver is able to cut through water in a swimming pool. Which property of matter does this observation show? Answer is, as the distance between the water particles is more and force of attraction between them is less as compared to solids, a diver is able to cut through water in a swimming pool easily. Question 4. What are the characteristics of the particles of matter? Answer is, as we have already read in the chapter, particles of matter have three basic characteristics. First one is particles of matter have space between them. Second one is particles of matter attract each other. Third one is particles of matter are continuously moving. Fifth question is, the mass per unit volume of a substance is called density. The formula is given as density is equal to mass upon volume. Arrange the following in the order of increasing density: air, exhaust from chimneys, honey, water, chalk, cotton, and iron. The answer is, we know that in a given volume, solids have maximum number of particles. Means their mass will be maximum as compared to liquids and gases. So their density will also be maximum. So the order of increasing density of states of matter is gases, then liquids and solids. So order of increasing density will be air, then exhaust from chimneys, then cotton, then water, then honey, then chalk, and finally iron. Question number 6, Part A. Tabulate the differences in the characteristics of states of matter. Part B. Comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. You may refer my previous video titled Matter in Our Surroundings Part 2, where I have explained the characteristics, properties of states of matter. Question number 7. Give reasons. Part A. A gas fills completely the vessel in which it is kept. Answer is, gas particles have high kinetic energy. They roam around freely in the vessel they are kept in. They occupy the whole space inside the vessel. Part B. A gas exerts pressure on the walls of the container. Answer is, gas particles have high kinetic energy and keep roaming around freely in the vessel they are kept in. They keep hitting each other as well as the walls of the container. This continuous collision exerts pressure on the walls of the container. Part C. A wooden table should be called a solid. Answer is, a wooden table shows all the properties of a solid. It has definite shape, definite volume, no compressibility, no fluidity, and high density. Part D. We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Answer is, particles of gases are far apart. They have least force of attraction between them, so it is easy to cut through the air. On the other hand, particles of solids are closely packed. They have highest force of attraction between them, which is not easy to break. So we need a karate expert to break a solid block of wood. Question 8. Liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. Answer is distance between particles of ice is more than that of the particles of water. So volume of ice is more and density is less as compared to water. Any object that has less density than water floats on the water. Question number 9. Convert the following temperature to Celsius scale. Part A 300 Kelvin, Part B 573 Kelvin. So we will use the formula capital T is equal to small t plus 273, where capital T denotes the temperature in Kelvin and small t denotes the temperature in Celsius. If you put the value of capital T as 300 Kelvin, small t can be calculated as 27 degrees centigrade. Similarly, we can calculate small t in part B, which will come out to be 300 degrees centigrade. Question 10. What is the physical state of water at 250 degrees centigrade and at 100 degrees centigrade? So at 250 degrees centigrade, water will be in the form of water vapor, which is gaseous state. 100 degrees centigrade is the boiling temperature of water. So it will be in liquid gas intermediate state. Question 11. For any substance, why does the temperature remain constant during the change of state? Answer is, during change of state, temperature remains constant as heat absorbed is used to weaken interparticle attraction forces. For example, during solid to liquid state change, heat absorbed is used to melt the solid, and during liquid to gas state change, heat absorbed is used to boil the liquid. Question 12. Suggest a method to liquefy atmospheric gases. Answer is, in order to liquefy a gas, interparticle distances have to be reduced. This can be done either by increasing pressure or decreasing temperature. Question 13. Why does a desert cooler cools better on a hot dry day? Answer is, on a hot dry day, humidity is less, so rate of evaporation increases. Water present inside the desert cooler takes heat from the inside surroundings and gets evaporated rapidly. As an effect of evaporation, surrounding air gets cool. Question 14. How does the water kept in an earthen pot, that is called matka, becomes cool during summer? Answer is, earthen pot has high number of pores. Some water particles absorb heat from the inside surroundings, seep through the walls and evaporate through these pores. This continuous process keeps the water cool. Question 15. Why does our palm feel cold when we put some acetone or petrol or perfume on it? Answer is, when we put some acetone or petrol or perfume on our palm, it absorbs the heat from the palm skin and evaporates. As an effect of evaporation, environment gets cool, so our palm feels cold. Question 16. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? Answer is, rate of evaporation increases with increase in the surface area. When we pour hot tea or milk in the saucer rather than in a cup, surface area for the liquid is increased. So steam can evaporate quickly and we can sip hot tea or milk faster. Question 17. What type of cloths should we wear in summer? Answer is, we should wear cotton cloths and light colored cloths in summer. During summer, we sweat more because of the mechanism of our body which keeps us cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. As an effect of evaporation, our skin feels cool. On the other hand, light colored cloths absorb less heat. Now we will see exercises questions. Question 1. Convert the following temperatures to the Celsius scale. Part A 293 Kelvin, Part B 470 Kelvin. So we will use this formula, capital T is equal to small t plus 273, where capital T is temperature in Kelvin and small t is the temperature in Celsius. Put the value of capital T as 293, so small t can be calculated as 20 degrees centigrade. In part B, put the value of capital T as 470, So small t will be calculated as 197 degrees centigrade. Question 2. Convert the following temperatures to the Kelvin scale. Part A 25 degrees centigrade, Part B 373 degrees centigrade. Again we will use the same formula as in question 1. Capital T is equal to small t plus 273, where capital T is temperature in Kelvin and small t is temperature in Celsius. Here small t value is given as 25. So substitute the value. Capital T can be calculated as 298 Kelvin. In part B, substitute the small t value as 373. So capital T will be calculated as 646 Kelvin. Question 3. Give reason for the following observations. Part A. Naphthalene balls disappear with time without leaving any solid. Answer is, naphthalene balls when exposed to air change from solid to gas particles without changing into liquid state. This process is known as sublimation. That is how they disappear without leaving any solid. Part B. We can get the smell of perfume sitting several meters away. Answer is, particles of perfume are gas particles which diffuse in the air. They have high kinetic energy to travel fast in the air. That is how we can get its smell sitting several meters away. Question 4. Arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. Answer. As we know, forces of attraction between the particles is highest in solids, then liquids, and least in gases. So its increasing order will be oxygen, then water, and sugar. Question 5. What is the physical state of water at 25 degrees centigrade, 0 degrees centigrade, 100 degrees centigrade? At 25 degrees centigrade, water is in liquid state. At 0 degrees centigrade, water is in solid state in the form of ice. At 100 degrees centigrade, water is in gaseous state in the form of water vapor. Question 6. Give 2 reasons to justify water at room temperature is a liquid. Answer is, water at room temperature shows these 2 properties. First, it takes the shape of the container it is put in. Second, it shows the property to flow, that is fluidity. Both are the properties of a liquid. Second part, an iron almirah is a solid at room temperature. Answer is, almirah at room temperature shows these 2 properties. First, its shape is definite. Second, it is a rigid body. Both are the properties of a solid. Question 7. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Answer is, 273 Kelvin is equivalent to 0 degrees centigrade, which is melting point of ice. During state change from ice to water, it absorbs latent heat of fusion, which is effective in cooling. Water at 0 degrees centigrade does not have this latent heat. Question 8. What produces more severe burns, boiling water or steam? Answer is, steam when changes to water releases latent heat of vaporization, which causes more serious burns as compared to boiling water at the same temperature. Last question. Name A, B, C, D, E and F in the following diagram showing change in its state. From solid to liquid is marked A, that is fusion. From liquid to gas it is marked B, which is vaporization. From gas to liquid is marked C, which is condensation. Liquid to solid is marked D, which is solidification. From solid to gas is marked E, which is sublimation. From gas to solid is marked F, which is deposition. So, talking about completion level questions and answers, we will see one more phenomena which is similar to diffusion. Osmosis. By definition, osmosis is the process by which particles of a solvent tend to pass through a semi-permeable membrane from a less concentrated solution into a more concentrated solution. Let us understand what does this mean. Suppose this is a beaker. A semi-permeable membrane is kept in the middle of this beaker. Imagine semi-permeable membrane as a thin sheet which allows only few particles to pass through it and blocks many. Now equal volume of water is poured on both sides. On the right side, 2 spoons of sugar is added, and on the left side, 10 spoons of sugar is added. Here solute is sugar and solvent is water. On the right side, where sugar is less concentrated solution, and on the left side, where sugar is more concentrated solution. Now water particles from both the sides will try to pass through the semi-permeable membrane. On the right side, sugar particles are less in number, so there are less obstacles for water particles to move towards the left. So the net movement of water particles will be from right to left, that is from lower concentration solution to higher concentration solution. This movement of particles is never ending even if equilibrium is reached, means concentration of the solution on both the sides is equal. This phenomena is known as osmosis. Example of osmosis is water transportation in plants from roots to leaves and other parts. Difference between osmosis and diffusion. There are two key differences between osmosis and diffusion. First one is osmosis requires a semi-permeable membrane while diffusion does not. Second one is osmosis can only function in a liquid medium, but diffusion can function in all three mediums, solid, liquid and gas, as we have already seen in this chapter. Difference between evaporation and vaporization. The main difference is evaporation happens below the boiling point of the liquid, whereas vaporization starts at the boiling point of the liquid. Now let us see some NCERT exemplar questions. First question is, which one of the following sets of phenomena would increase on raising the temperature? First phenomena is diffusion. On temperature increase, diffusion gets quicker. We have already seen the example of hot sizzling food, so this is correct. Second is evaporation. We know that rate of evaporation increases on increase in temperature, so this also is correct. Third is compression of gases. In this piston cylinder example, we have seen when pressure is increased, gas changes to liquid or solid, and we know that gas changes to liquid because of cooling, means temperature decreases, not increases. So this compression of gases is wrong. It should be expansion of gases. So option C is correct. Second question. Seema visited a natural gas compressing unit and found that the gas can be liquefied under specific conditions of temperature and pressure. While sharing her experience with friends, she got confused. Help her to identify the correct set of conditions. We have to identify temperature and pressure conditions. Here the gas is getting liquefied, means it is getting cooled, that is temperature is decreasing. So either A or C option is correct. For pressure condition, when piston is pushed down the cylinder, pressure is increased. The distance between the particles is decreasing, means gas will change to liquid. So high pressure is the correct option. So the answer will be low temperature and high pressure. Third question. The property to flow is unique to fluids. Which one of the following statements is correct? First option is only gases behave like fluids. Second option, gases and solids behave like fluids. Third option, gases and liquids behave like fluids. Fourth option, only liquids are fluids. We know that only gases and liquids show fluidity. Gases are more fluid than liquids. So the correct option is option C. Fourth question, which condition out of the following will increase the evaporation of water? First option, increase in temperature of water. Second option, decrease in temperature of water. Third option, less exposed surface area of water. Fourth is adding common salt to water. Let us see all the options one by one. First option is increase in temperature of water. If temperature of water is increased, more water particles will get enough kinetic energy to overcome the forces of attraction with other particles. That means evaporation of water will increase. So this option is correct. Let us see other options as well. Decrease in temperature of water is clearly the opposite of option A, so it is wrong. Less exposed surface area of water is wrong option. We know that surface area should be increased to increase the rate of evaporation. Fourth option, adding common salt to water. We know that only four factors are responsible for rate of evaporation to increase, and they are increase in surface area, increase in temperature, decrease in humidity, and increase in wind speed. That means this option is wrong. The correct option is option A. Fifth question. In which of the following conditions the distance between the particles of hydrogen gas would increase? First statement is increasing pressure on hydrogen contained in a closed container. We have seen in piston cylinder example that if the pressure on the gas is increased, it will decrease the distance between the particles. So this statement is wrong. Second statement is some hydrogen gas leaking out of the container. Volume of the container is fixed. If some gas particles move out of it, there will be lesser number of particles. That is, distance between them will increase. So this statement is correct. Third statement is increasing the volume of the container of the hydrogen gas. If the volume of the container is increased and number of particles are same, obviously distance between the particles will increase. So this statement is also correct. Fourth statement is adding more hydrogen gas to the container without increasing the volume of the container. If more hydrogen gas is added to the same container, number of gas particles will increase. That is, distance between them will decrease. So this statement is wrong. Only second and third statements are correct. So option C is right. Short answer questions. A sample of water under study was found to boil at 102 degrees centigrade at normal temperature and pressure. Is the water pure? Will this water freeze at 0 degrees centigrade? Comment. Answer is, we know that pure water boils at 100 degrees centigrade. Since this sample of water is boiling at 102 degrees centigrade, so the water is not pure. Pure water freezes at 0 degrees centigrade. Since this water is not pure, so it will not freeze at 0 degrees centigrade. Second question. A student heats a beaker containing ice and water. He measures the temperature of the content of the beaker as a function of time. Which of the following would correctly represent the result? Justify your answer. Temperature will remain constant at 0 degrees centigrade till the ice melts completely. Only in option D, temperature remains constant at 0 degrees centigrade, then it increases to 100 degrees centigrade. So option D is correct. Third question. Classify the following into osmosis or diffusion. First part is swelling up of a resin on keeping in water. First, we will see the presence or absence of semi-permeable membrane. If this membrane is present, it will be osmosis, else diffusion. In this case, resin's skin works as semi-permeable membrane. Since water concentration is more outside of resin, so it will move inside the resin through the membrane, causing the swelling up of resin. Second part is spreading of virus on sneezing. It is diffusion. Sneeze comes out of nose in the form of small water droplets containing virus, which diffuses in air. There is no semi-permeable membrane between nose and air, so it cannot be osmosis. Third part, earthworm dying on coming in contact with common salt. This is osmosis. On coming in contact with common salt, water comes out of earthworm's skin. Here earthworm's skin works as semi-permeable membrane. Due to loss of water, its skin dries up. Fourth part, shrinking of grapes kept in thick sugar syrup. This is osmosis. Water in the grapes comes out of its skin due to osmosis. Because of water loss, grapes shrink. Next part, preserving pickles in salt is osmosis. Due to the presence of salt, water comes out of pickle's content through its skin. Loss of water helps preserve pickle. Next part, spreading of smell of cake being baked throughout the house. This is diffusion. Smell of cake contains gas particles which diffuse through air. Due to their high kinetic energy, they travel a long distance and spread throughout the house. Last part, aquatic animals using oxygen dissolved in water during respiration. This is diffusion. Oxygen is dissolved in water due to diffusion. Aquatic animals use this oxygen during respiration. Long answer questions. First question, you are provided with a mixture of naphthalene and ammonium chloride by your teacher. Suggest an activity to separate them. Answer is, put the mixture on a plate and spread it evenly. Now put the plate in a closed vessel and start heating the vessel. Naphthalene at room temperature sublimates, that is, it changes from solid to gas without leaving any solid residue. Naphthalene will be deposited on the inner walls of the vessel. Only ammonium chloride will remain in the mixture. Second question. You want to wear your favorite shirt to a party, but the problem is that it is still wet after a wash. What steps would you take to dry it faster? The answer is, to dry the shirt faster, spread and keep it under running fan at full speed. Water particles will be blown away quickly as the rate of evaporation increases with the increase in wind speed. Now let us see some Olympiad questions. I have taken these questions from NSO Olympiad workbook by MTG Learning. First question. Read the given passage and fill in the blanks by selecting an appropriate option. 1 is highest in solids while 2 is highest in gases. Gases and liquids both have high 3. So 1, 2 and 3 consists of some keywords. We have to choose the right combination of keywords which fill the blanks. So options A, B, C and D are given. One of these is correct. Let us see. 1 is highest in solids. So out of 3 keywords, fluidity, density and rigidity, we have to choose. So what is highest in solids? It is either density or rigidity. It cannot be fluidity. So option A is wrong. Let us see the second keyword. Is highest in gases. So what is highest in gases? Density, fluidity or compressibility. It is either fluidity or compressibility. Let us see the third one. Gases and liquids both have high compressibility, rigidity, density or fluidity. It is fluidity. So all the 3 keywords which are correct is in option D. That is rigidity, compressibility and fluidity. Second question. Read the given statements and mark the correct option. Statement 1. Pieces of dry ice gradually get smaller when left at room temperature. Statement 2. Dry ice undergoes sublimation. When you read the options A, B, C, D, what you need to do, first you need to figure out whether statement 1 and 2 are true or false and statement 2 is the correct explanation of statement 1. Let us figure out. Statement 1 is, pieces of dry ice gradually get smaller when left at room temperature. You know that dry ice is also known as solid carbon dioxide. When left at room temperature, it sublimates, means it directly changes from solid state to gas state and changes into carbon dioxide gas. And statement 2 is, dry ice undergoes sublimation, which is correct, means solid directly changes to gas without passing through liquid state. So option A, which is both statements 1 and 2 are true, is correct, and statement 2 is the correct explanation of statement 1, which is also correct. So correct option is option A. Third question. The freezing and boiling points of a substance P are minus 220 degrees centigrade and minus 185 degrees centigrade respectively. At which of the following range of temperatures will P exist as a liquid? We know that water's freezing point is 0 degrees centigrade and its boiling point is 100 degrees centigrade. Between these two temperatures, water exists as a liquid. Similarly, it is given as the freezing point of substance P is minus 220 degrees centigrade and its boiling point is minus 185 degrees centigrade. Between these two temperatures, it will exist as a liquid. So let us see among which options A, B, C, D is the correct one. First is between minus 175 degrees centigrade and minus 210 degrees centigrade. So let us see. Minus 175 degrees centigrade will come to the right of minus 185 degrees centigrade. So it will be out of range. So this option is wrong. Second option, between minus 190 degrees centigrade and minus 225 degrees centigrade. Minus 190 degrees centigrade will be between the range, but minus 225 degrees centigrade will be left of minus 220 degrees centigrade, so it will be out of range. So this option is wrong. Option C, between minus 200 degrees centigrade and minus 160 degrees centigrade. So minus 200 degrees centigrade will be within range and minus 160 degrees centigrade will be out of range. It will be right of minus 185 degrees centigrade. So this option is wrong. Option D, between minus 195 degrees centigrade and minus 215 degrees centigrade. So minus 195 will be within range and minus 215 degrees centigrade will also be within range. So this is the correct option. Fourth question. A brief information about three substances is given in the table. Substance name is P, Q and R and their melting and boiling points are given. Now the question is, which of the following is incorrect about these substances? So you have to figure out incorrect statement. First choice is, at room temperature, substance P will have fixed volume but no fixed shape. That means it will be in liquid state. Let us check. Substance P's melting point is 23 degrees centigrade and its boiling point is 60 degrees centigrade. So room temperature is in between these 2 points. That means P will exist in liquid state. So option A is correct. Option B. At room temperature, substance Q will have maximum space between the particles. Means it will exist in gaseous state. Let us check. Its boiling point is 20 degrees centigrade. So room temperature will be above the boiling point. Means it will exist in gaseous state. So option B is also correct. Let us check option C. At room temperature, substance R will have strongest interparticle forces. Means it will exist in solid state. Let us check. Substance R's melting point is 65 degrees centigrade, which is much above the room temperature. So R will exist in solid state. So option C is also correct. So all these A, B, C options are correct. So option D, which is none of these, means none of this statement is incorrect, is the correct choice. Last question. Study the given heating curve of substance X carefully and select the correct statement. Let us study the curve first. X-axis represents change of state and Y-axis represents temperature in Kelvin. 273 Kelvin is freezing temperature, 373 Kelvin is boiling temperature. At point P, substance X is in solid state. Between P to Q, temperature rises. Between Q to R, temperature is constant, means it undergoes state change from solid to liquid. Between R to S, temperature rises from 273 to 373 Kelvin. And between S to T, it again undergoes state change from liquid to gaseous state. And beyond T, it is in gaseous state and its temperature rises again. So let us check the options. Option A is substance X exists in solid state at point 1. That is correct. In liquid state at point 3. That is also correct. In gaseous state at point 5 is also correct. So option A is correct. Let us check option B. QR represents latent heat of fusion. That is correct because it undergoes state change from solid to liquid between QR. While ST represents latent heat of vaporization. That is also correct because between ST it undergoes the state change from liquid to gaseous state. So option B is also correct. Let us check option C. At QR, matter exists both in solid and liquid states. That is correct. While at ST, matter exists both in liquid and gaseous state. That is also correct. So option C is also correct. Let us check option D. All of these means all of these statements are correct. That is the correct option. You may practice more competition level questions. Relevant links are given in the description box below. If you have any doubt, you may join our Discord server. Please subscribe our YouTube channel if you have not already done yet.